Chiki, can you see the slide? Makita ra ang slide? Okay, sige. So, traversals of a directed graph. Kung paspas ra kayo, if you're going to snip, just tell me. Teka lang, mangita pa og position, dili mahanginan akong eyes. May sakit, sakit siya. Sakit kayo siya mahanginan. Yeah, di man pwede ang computer, di na ko electric fanan. Okay, so if you recall trees and graphs are related. So, unsa kay true ani all trees are graphs or all graphs are trees. So, you try to consider that one. Kamo na ang mo answer ana. All trees are graph, all graphs are trees. Okay, and if you recall, there are three systematic ways of organizing nodes in the tree. Nigawas ni sa test ang isa, pre-order. So we have that one. And then in order. And then post order. So, kabaw naman mo ana no? Possible ba mo gawas ni sa test? Possible gihapon. Ay, because ang finals test is from the beginning man. That's why 30% ang finals. Okay. So, skip na lang ko ani ha. Kaba naman mo aning pre-order, in order, and post-order. Pwede rin nyo snip po that you can practice. You can ano. Pero if you have the code already of pre-order, in order, kaya rin na siya. Although, dili mo, you cannot make an exercise on this because this is a general tree wherein nodes can have two or more children. Dili ni siya binary tree. Okay, sige, sa graph traversal na ta. There are actually two, but we will be discussing here one lang because the other one, ato sa next slide. So, DFS or depth first search, a systematic way of visiting vertices and arcs. It's called depth first search because it is continuous searching in a forward or deeper direction. Sige, what is the Visayan word for depth?
Laom.
Ha? Kyle?
Laom.
Yaw. Gilaw mun. Laum. You said laum, Kyle? Yeah. Gilaw mun. Okay, laum or gilaw mun. So like the depth of the ocean. Okay, and it's considered as a generalization of pre-order traversal. So the DFS, this recursive function is actually just a pseudocode. So I would like you to look into this book. Nahatag na ba din ako? Data Structures in Pascal? In Pascal, did I mention this by Aho? Naana mo everyone, kindly download this one. Naara gid dito tanan akong nakaling sa graph, Hofcroft and Ullman. And Ullman, naara gyud dito. And then kani sad siya because this is a pseudocode. Although most of the algorithm is in Pascal, but this one is a pseudocode. So kani siyang DFS. Eksakto gyud ni from there akong gikuha. Okay, so download daw po lang ni everyone, makita na siya. So here we have you have to think of the data mo na ni siya mo gawas ang inyong knowledge in data structure. So what would be the appropriate data structure to. And by the way, in this book, katong sa Pascal, pag if it's something that returns, diba sa C, we call the subroutine functions. So, whether it returns something explicitly or not, ang tawag nato sa function. Sa Pascal, kung if the subroutine will not return anything, ang tawag niya procedure. Pero if the subroutine returns something, ang tawag niya function. And in Java, whether mo return or dili, you call it method. So we're just talking about terminologies here. Ana ra. So function man ang con, that means mo return something supposedly here. Okay, so mark here, as you notice, ni-access na yung index. So mark is a one-dimensional array. And then notice na wala siya initialize. So it could be something that is out or global variable ang ihang pag-access ani. And then you have another data structure here kaning LV, dili ni siya Louis Vuitton, but this is the adjacency list. Diba? There are two ways to represent a graph, adjacency matrix or adjacency list. And you can even have a labeled adjacency matrix wherein what you put inside that the square matrix or two-dimensional array are the weights. So sa labeled adjacency list also, pwede sa di mo butang weights. Okay, so this vertex, this is marked, this is initialized to be all the vertices here from 0 to 6 unvisited. Very well, ha? For a while, ha, nagpalista po ko sa clinic. Okay, so the U there for unvisited. I-shortcut lang na ako and then here it's visited. So unvisited, visited. Okay, so if you are given this graph, mo ni ang iyang labeled adjacency labeled adjacency list. So 0 has two adjacent vertices which are 1 and which 2. So mo ni siya no. Kibaw naman ta ani. So let me continue. There. And then I'll just do a shortcut here. Butang na ako sa taas. So you may snip this one so that you will have a visual. Although ako na siya butang sa taas. So there. That is the function. And then wala si mark. And then this is the adjacent. This is my shortcut for the adjacency list. So adjacent vertices for 0, 1, and 2, for 1, 2, and 3. Dara-dara siya. Para mo fit sila sa whole slide. So when you call the DFS and you start with 0, but you always start with 0. Dili necessarily a 0. It's anywhere. So this is the difference between the graph and the tree, because the tree, we always start at the root. Except for POT, we start at the leaf level. So kani, we start, most of the trees, we always start with the root. Like for example, the traversal, we order in order. Ato ka sa root of the tree. Pero sa graph, because there's no such thing as root here, so very general siya, then that means you can start anywhere. So in my simulation lang, I start with 0, but later on, you can start with, you can start with any vertex again. Okay, balik ko no. So call the FS passing 0. So that means the V here is equal to 0. And then we start with the red colored statement that is mark it visited. So muna siyang, instead of a U, you have there visited. Then for the for loop. So for the loop, for each vertex, so meaning all of the vertices, for each of the vertices in LV, so in index 0, you have two vertices, 1 and 2. So muna siya. Oh, wait. By the way, we can also start drawing the DFS spanning forest. So start at 0 there. You have, so for each of the vertices, 1 and 2, asa man nakuhaon ang 1 and 2 dire? Here. So if mark W, start with the first one, 1. If mark W is unvisited, which is true here in mark, so we have to call DFS. So diri ang recursion. So there, mag-DFS1 ka. Now take note that sa first call, wala pang ma-finish ang first call na apay nahabilin. Napay nahabilin na W is equal to 2. So because this is a new recursive call, then that means balik na pud sa uno. And then in terms of execution stack, meaning mupatong mag-create ang activation record here. So mark it visited, and then every time you mark it visited, imo na pud ni siyang i-add diri sa DFS spawning forest kani siya. And then this kani akong gidrawing sa left sa right side kani siya. This using linked list, i-implement na pud na nimo, and then unsa ang mga nodes na na-enter nimo first, followed by the next node, enter next. Okay, or you can enter the edge. So like 0, 1, and then take note of your root of the tree. Okay, so the two vertices adjacent to 1, you have 2 and 3. And then again, the first one, mark 2. So kaning first one, 2 unvisited, which is true. So you call the FS again. And this time, wala pa gyud na finish ang second call. Ang first call pod, wala pa na finish. So this is the third call. You have mark 2 visited, DFS2, and then mark 2 visited. So you have visited there. And then, nari siya. So ganang diri man sa 1 because ni call tag di 2 is adjacent to 1 from here. And then for each vertex again, W on LV. So unsa man ning vertices adjacent to 2. So 0 ra. Okay. Take note that 0 is already visited. So what we do is dili ta mo call of the FS, but we are going to mark at that as a broken arrow. Okay, question so far? So kay visited man siya, then there is no call. So dili mo all call mo end ang third call. Di ba mo ni ang first DFS 0, ang second DFS 1, ang third kay DFS 2. So mo end ang third call and mo resume siya to the second call. So sa second call na pay nahabilin na 3 here. So balik na sa diri sa green colored statement is mark 3 unvisited, which is true. Sorry. Okay. So since it is unvisited, so mo call na po siya DFS. So this is a fourth call, but kung sa execution stack pa ni, tulura ni ka activation record. Ang DFS 0 muna yung first call, on top of it DFS 1 muna ang second call, and then when the third call katon DFS 2 ended, so na-out na po to siya sa execution stack. Bali ang nasa execution stack karon tulo lang ka activation record. The first call, the second call, and then the fourth call. Kaning DFS 3. So we go back again to the red color statement. You have mark 3 visited. So there. Visited siya. And then for each vertex adjacent to, visited man kanisa. Okay, nganong 1 to 3 man because 3 is adjacent to 1 here. Okay, so what are the vertices adjacent to 3? We have 0 and 2. So we know that both 0 and 2 are visited. So no more call, but we'll draw broken lines. Okay. The broken lines, I also color coded it. Kung pareha sila na broken lines, so duha ka green, pareho na sila. And then this red, lahi na siya. So because there are also kinds of arc, kanang arcs. Kadiyot sa mura ko gihuba. Parang I got cold virus. Actually, nigawas ko gapon and then murag naka-pick up ko cold virus. I don't have fever, but ano, anyway. So this is the end of the fourth call. So end of the fourth call, mo go back siya sa second call. And then sa second call, that's also the last statement. So mo input ang second call. So mo balik siya sa first call. And since that's also the last statement, di pa di, you have 2. So mark 2 is unvisited is false. So mo nang from 0 to 2, na siya nga line. Okay. So, and then mo end na siya. Notice here that not all vertices are visited. So, possible na siya. Possible sad nga tanan ma-visit right away. But I'm illustrating this because of the possibility. So, I think mo ba ito ni example? Okay, anymore. I think mo ni example sa book. Mo ba ni? Di ko sure. I forgot. So, anyway, if that will happen, mo ni siyang made global ni siya. Dapat global ni siya, or if it's not made global, it is initialized outside. It's initialized outside and passed to the function. So, and so that you will know ang data structure aning mark, so that you will know that everything is not mark visited. Pwede nini mo siyang ihimo og structure with account. Count nimo kung pila na ka book ang visited. So, muna siya. So what will happen? You're going to call DFS again, DFS, and then starting with any vertex that is not visited. So predict 4, predict 5, predict 6. In my case, I just call them in ascending order. So that one. So again, pwede regug 5, pwede regug 6. So since this call is independent of katong call ganina, kana independent man siya. So when we do this, we mark it visited here. So that's the red colored statement. And then lahi pud ang iyang tree na ma-create. So dili siya connected. So we have here what are green colored statements. So the vertices adjacent to 4, you have 5 and 6. So start with 5. So mark 5 is unvisited, which is true. So they call siya DFS 5. Okay. So green colored, red colored statement, mark it visited, and then you have that one also. And then there, one is visited. So muna siyang red colored statement. Kani siya of from 5 to 1. Broken nga arc. So end of DFS 5. Going back to that call, and then DFS 6. Mark it visited. That one there. I'm just using a drawing. You can use a, what do you call this one? A structure that will represent not only a single tree, but 2 trees. So that means you can have roots there. So it's your design. So 3, 3 is visited, so mag-broken line ta from 6 to 3. And then 5, oops. So 5 is also visited, so mag-broken line ta from 6 to 5. And then this is the end of this call and the end of this call, and mark the array mark are all the vertices are visited. So that means there. You can put DFS in a loop while while all vertices are visited, and then you do DFS. So pwede po na siya. Part of that. So what we have created here is a depth first spawning forest. What is a forest? A collection of trees. So this is one tree and this is another tree. So that's the DFS spawning forest. So it is possible to create two trees. Most of the time, one tree lang. Depende. So in your exercise, one tree lang ang mugawas. Usara ka tree. So what are these colored arcs and block arcs? So we have what we call as tree arcs. So the arcs leading to new unvisited vertices are called tree arcs. So muna ang mga block solid arcs. They are called the tree arcs. So bale in your DFS spawning forest, sila lang na ang mo appear kaning mga block arcs. So there are 1, 2, 3, 4, 5 arcs. Okay. And then so three arcs form a depth first spawning forest for the given diagram. So what is a forest? A forest is a collection of one or more trees. So monang forest, kay dili naman usara ka tree ang possible na ma-create. You could have one, you could have two, you could have three, and so on. And what about the colored arcs? They are called, there are other arcs. So ang kanang mga green kay back arc, tanawa, you have two green. Why is it called a back arc? LCC. LCC, pabasa ti kaani. Is a non-tree arc which goes from a vertex to one of its ancestors in the spawning forest. Example 3 to 0. So, muna ang back arc. Sige, everybody, I'd like you to read back arc. Kay kamo ang muhimo sa definition sa sunod nga arc. Sige, go everyone. In chorus. I did this and also in face-to-face. Go everyone.
Back arc.
Back
Back
arc
arc
is
is
a
a
non-tree
non-tree
arc
arc
which
which
goes
goes
from a
from a
vertex to
vertex
one
to
of
one
its
of its
ancestors
ancestors
in
in
the
the
spawning
spawning
forest.
forest.
Okay, ayun na lang ang example. Sige na lang na. Kotoban niya. Sige. The next arc is this. Sige. Define forward arc. LCC, Lord Christian.
Rose from
LCC, Justin. Si LCC ako tawag. Si Christian.
Kanang pinabalira, ma'am.
Oh, define nga.
Oh,
You
man.
define it. Sige. Is a forward arc is, and then continue.
Is a non-tree arc which grows from the... So, from one to vertex of its ancestors in the spanning forest.
Ingon ka pa bali. Di
Oh,
pareho ra lagi imong giingon. You're
ay
just
di,
reading back arc. You're just reading back arc. You are to
balira
create.
na ako ang one to vertex.
Sige, kuan. Sige again.
Oh,
Sige na lang, Justin. I'm really in a hurry but I won't be looking at the screen. Nagsakit agad ako mata. Sige, go Justin. Try. Go Justin.
it's a non-tree arc which goes from one of its ancestors to a vertex
Ay,
in the
I
spawning
know, I
forest.
know. You just read that one. From a vertex to, sige.
From
I-change lang. Sige, go,
uh,
Justine.
which goes from one of its ancestors to a vertex, miss.
No. Another one. Same na ang ano, same na ang first line. Anyone? Anyone who would try? Jay? Jay.
Hello, Miss. Hello.
Yes, Jay. Ikaw lang, Jay.
Um, um, non-tree arc.
Kumpleto ha, Jay.
Uh,
Forward arc.
Forward arc is a non-tree arc which goes from a vertex to one of its descendants in a spanning forest.
Yes, Jay. Thank you. So, mo ni siya. That is why I asked you to read. Para when you're reading, you can contemplate ka and then look at the drawing. That's correct. Instead of ancestor, descendant. Thank you, Jay. And then the cross arc. So you have the red statements. The red arcs. So they are also non-tree arcs, which goes from a vertex. So here, from a vertex to another vertex, that is neither an ancestor nor a descendant. So 6. Sorry, 6, 5. 6, 5. 5 is not an ancestor of 6, nor 5 is a descendant of 6. Pwede sibling. Sibling sila. Pero dili ancestor, dili descendant. So 5, 1. 1 is not an ancestor of 6, nor 1 is a as of 5, nor 1 is a descendant of 5. Okay. Next, so you may snip that one if you want to read it again and try to comprehend. So what I want you to do now is to do the same thing, simulate. So given the same graph and then the same adjacency matrix, nganong mingon man kog same adjacency matrix? Because ang adjacency matrix could be arranged in different order. Tanawa good kaya ako sa niyo after sa niya ako ha. Asa na to? Tanawa ra good yung adjacency matrix nga na-produce here kani siya. Gi-arrange ang vertices in ascending order. Adjacent vertices tumunang 1 and 2, 2, 3. So because it is possible to arrange them in different order, like for example, descending. So for example, instead of 1, 2, mahimo siyang 2, 1. So if it's descending, iba na po na DFS spawning forest ang makuha. So different order of vertices will give us a different spawning forest. Sige, balik ko dito sa exercise. You have this one. So muna niyo ko given the same graph and adjacency list, kay same because still arranged, the adjacent vertices are still arranged in ascending order. So what you're going to do is to simulate DFS and draw the DFS spawning forest, this time starting with vertex 4, delete with vertex 0. So starting with vertex 4, not with vertex 0. And if ever the function call will terminate and not all vertices are visited, then mo call ka DFS again using the remaining vertex with the lowest value. So pananglitan, mo end ang call tapos like what happened here, asa na to? Here, ni-end ang call and then not all vertices are visited. So ni call ta again starting with 4. So but this time we don't start again sa exercise. You don't start, oops, dili na. Oops. Wala ta di ta mo start sa DFS 0 or kamo di mo start sa DFS 0 but mo start mo with 4. Okay? Everyone? Nakakuha? Hello? Nakakuha? Nakuha ra. Sige, okay. Naman siguro ni, this is another exercise. This one is another exercise. Pero, so there are 2 exercises. Ang first one is, ang katong adjacency list. is arrange in ascending order and then start with the FS4. Kani siya. Ang second is the FS4 gihapon but descending order. Descending order. So I want you to wait lang. Yeah, I want you to I want you to see the differences. We are talking about the same graph, but with starting with the same vertex but different ang graph. I want you to see nga kung lahi ba ang mugawas. But yeah, I will assure you lahi ang manggawas. So, muskip lang ko ani ha. You just do this on your own. Mupadayon lang ta. So, kanina ta. The FS number. Ganahan ako mo. Sakit kay kong mata. Sakit akong mata. So, another term is DFS number. So, unsa man ang DFS number? DF, depth first number pala. So, it is a number assigned to the vertex according to the order in which the vertex was marked visited. So, this is our first example na start at index 0. So, ang iyahang DFS number will be a 1. Ya, ang sunod kay ang kaning 1 will be a 2. Ya, na-timingan lang good nga ang 2 is a 3 sunod. Pero in your exercise nga nag-start mo with DFS4, so in that exercise the DF number of 4 will be 1 kay siya man ang unang gi-call. You get that one? Christian Anthony, did you get that one? So in my example, my first example, kay I started with the FS0. So its DF number is a 1. So on. So it just so happened in this exercise. So but then in your exercise, your DF number C4 sa DF sa exercise ninyo wherein you call the FS as wait lang. Here. Since you call 4 first, so the DF number of 4 here will be 1. And then whatever will be called next, so ma-call next ani kay si 5. So si 5 will have DF1. And then di sa kumingon kung next ba si 6 or si 1 sa inyohang DFS. So basta sure na from 4 you go to 5. But it's between 1 and 6. Ay, did you? 1 or 6 ba? Okay. Next, you have so this is continuation of that exercise. Katong you call the FS starting with 4. Dapat siguro na ako na siyang gisaka na lang anyway. So I already mentioned that DF number of 4 is 1 and then the DF number of 5 is 2. Pero I will not tell you the rest. So determine the DF search number, DFS search number of each of the vertices. Okay, so can you just read that one? Kana observation. Can you just snip that one? And then finally, you have this one, directed acyclic graph. Sige, ito i-play. Directed acyclic graph. So, acyclic, meaning not a cycle, is a directed graph with dot there. So, it's called a DAG. So, directed acyclic graph or acyclic is useful in representing syntactic structure. So, if you recall in trees, kung pa-drawing ng tag expression trees, di ba, we start with this one, dire, A plus B. So, muna siya. So, di ba sa expression trees, all the leaves are operands and then ang interior nodes are operators. So, muna itong operands, A plus B. Sunod, B minus C. And then, ang left operand sa multiplication is that one. Sa DAG, kay no repetition. Like for example, here, B is an expression. So, dili siya i-repeat. So, ano lang siya, and then, kani siya gi-stretch diya. Okay? So, ang practice ninyo kay kani. And then, hala, grabe sa practice ni ma'am. Tanawa ra gud ang mga repeated expression na A plus B repeated. Pila na siya ka-repeat o, day A plus B here, dapat yung A plus B here. Pero A plus B times C is also repeated na ay A plus B times C here. Dapat kausara na sila manggawas. So, mag-drawing mo o, hindi mo na yung makakita sa akong hand. Okay, anyway, sige, i-try lang na siya drawing and then I'll see your answer next meeting. So, basi, muna na siya. Malang na for now. So, bali, ang inyong exercise kay, oops, kay kani inyong exercise. Kani, sana to? Kani, nakuha na? Sige, ako assurance ninyo, lahi ang manggawas nga DFS Pudding Forest ani. Lahi pud ang mugawas ani. But to practice, dapat mo practice mo. And then, I just want to point out nga DFS Pudding Forest gani, kana rang block arcs. Kana extra na siya ang extra na siya ang broken line arcs. You can also do extra because possible po na siya magawa sa test. How many, for example, how many tree arcs are there? How many non-tree arcs are there? How many forward arcs? Okay, so kana, and then this exercise kani siya continuation na ni siya sa katong kani siya. So whatever tree DFS Panning Forest pala that you are going to produce here, so kana ra na siya, continuation 2A. Kani mabasa na ninyo mga observation na about DF number. And then the exercise. Okay, question? Ano lang sa for now? Kani? Yeah, okay. Mansa pa. Everyone? Jomer, naunsa ka? Jomer? Lantan ka? Sige mo rest naman ta. Kanilang for now. Para lang you have something kaysa wala. And then, i-try gud na ko next Wednesday. Try na ko na finish. Murag one slide naman lang. Hindi. Ito pa di ni. Napaday minimum cost panning tree. Ang Paris ani niya kay BFS but BFS breadth first search. So, mag-action ta ko. Ang DFS kay palalom. Ang katong BFS pa wide. So, width naman siya. Breadth. Sabay, ako type. B-R-E-A-D. Bread. Nga na I-T-H. Breath. Ana. So, it's breath. Naasa din siya. So, pwede sa din yung tanawon na gihapon ni siya dia and then wa man sad ko intention to what they call to simulate kay ano na gud siya klaro na kay siya ang iyahang the algorithm. So breath first search for BFS. So search in the book given. Search in the AHO book. Search in the AHO book. Then you can also start searching the internet. Ang BFS kay magkinahanglan siya og Q. So katong what are the Q operations you have? NQ, the Q. So what you can do is you can make a dot header file pareha sa gihimo sa stock. I think I asked you also to do sa queue. Wala ninyo gitiwas. So you can either do the linked list sa queue. Itong queue is a structure containing two pointers. The rear pointer or the front pointer, or ang pwede nyo gamitin katong circular array implementation of queue. So pwede yun. So you will just do the queue and then front. Kay mo gitawag ana atong sa libro sa BFS. So I'm still using that algorithm. Mo sa gihapon akong I'm not discussing it. I'm just showing it to student and then I tell them, okay, simulate using that one. Kay ma-simulate naman good siya good. Okay. Sorry class. Murag mo out. Sakit ako mata na. Sige